This lesson is referred to the page 108 of the book and is the second part of the lesson, the second video. Parallel circuits. Load devices are connected on different branches, okay? In these parallel circuits, they are connected in different wires. So there are several possibilities for the current to go through. Let's draw a parallel circuit. The current can take this path to get the negative terminal of the battery, or this path. Start from here and go to the negative terminal. So there are two possibilities, okay? In this case, the characteristics of this type of circuits are that the voltage is the same, in this resistor, and in the total circuit. Also, if a load device breaks, the circuit continues working, okay? To calculate this type of circuits is more or less the same with different formulas, but more or less is the same. The process is the same. So we know that I can relate the three parameters of the electricity in the load devices, okay? So I would have the resistance of the first resistor, the voltage in the first resistor, the current of the first resistor, and the resistance of the second resistor, the voltage in the second resistor, and the current in the second resistor. So I have three parameters related each other by the Ohm's law, but I can group them together in one. I calculate with the formula, with this formula, okay, to group them together. And I get the three more parameters that are the total resistance, the total voltage is the battery, and the total current, okay? So we have the parameters of each resistor and the total values, okay? Let's see how to calculate the resistance, how to group them together, because it's different. It's not only to sum both resistors, okay? So I'm going to do an example with small values like 1 ohm and 2 ohm, and the battery, well, doesn't matter because I want you only to calculate the total resistance of the circuit. So here I have the resistor 1 and have resistor 2. 1 divided by total resistance is 1 divided by R1, R2. Imagine this is the other formula is this one, but now are in the lower part of the fraction, okay? Are dividing. Let's see. 1 divided by 1 plus 1 divided by 2. I have to sum two fractions. How? I have to do the common multiple of both, which is between 1 and 2 is 2, no? So the equivalent fraction is 2 divided by 1 is 2, and this is the number that I have to multiply in the upper part. 2 divided by 2 is 1, so 1 I have to multiply on the upper part of the fraction, that is 1. Multiplied by 1 times 1 is 2. Now I sum them. This is 2 and this is 2 plus 1 is 3. Okay. Now, be careful because this is not the solution, okay? I'm going to go there. 1 divided by total resistance is 3 divided by 2. What I'm going to do is, what I have to do to solve this is to move the total resistance to the upper part. How? I have more than one way, okay? But the simplest one is to exchange the values. I mean, this go up and this go down, this go up and this go down, okay? So I exchange. Okay? The total resistance divided by 1 is the total resistance. So the resistance is 2 divided by 3, 0.6. Okay? This is one way. If I have two resistors, only two resistors in parallel, I can do it with another formula, but I want to follow this method, okay? Previous the formula. The formula, yes. Okay, so I introduce the values. R1, 1 multiplied by 2 divided in 1 plus 2. Okay, so it's the same result if you use this formula, but you can only use it when you have two resistors, okay? And let's practice this with the example on the page 111, okay? You have to write down the formulas, okay? Everything. I didn't say before, but it's important to have always the formulas. Write it down in your notebook in a paper. Let's see. Okay. parallel circuit. Page 111. I'm not going to convert to ohms because it's difficult to work with these two numbers because they are high numbers, okay? So let's see. Total equivalent resistance of the circuit. So I'm going to transform my circuit in one resistance. Let's do it in this place because I have more space. The formula is 1 divided by total resistance is 1 divided by resistor 1, 200 kilo ohms plus 1 divided 300 kilo ohms. The common multiple between them is 600. 600 divided by 200 is 3. Is 3, no? 600 divided by 2 is 3. So I multiply 3 by this number, so it's 3. 6,000 divided by 600 divided by 300 is 3. No, 2. Sorry, it's 2. I'm thinking, so I made a mistake. So it's 2. Now I can sum these two values, no? 6. 3 plus 2. Okay. Now what I do is move this up, move the other down. Okay. So okay. I calculate this value. So the result of this is the total resistance is 120 kilo ohms. Okay, and now I convert into ohms. 120 I multiply by 1000 and I get 120,000 ohms. Okay. Okay. B. Total current flowing. Total current, we are in the total values, okay? So, total current flowing through the circuit. I know two parameters, so I can calculate this relating with the Ohm's law. Can you see the parameters are total of all of them, okay? So 240 divided by 0.002 amps. Okay, the value of the current is a small number. Okay, it's a low number. The voltage across each resistor. Okay, let's see the formula. The formula I have, what I have the total voltage, the total current, and the resistor. Okay, the total resistor. Now the voltage across each resistor. I write the formula, and it's the total voltage is the voltage in the first resistor, and the voltage in the second one is the same. So the voltage, the total voltage is the battery. Okay, is the voltage supplied by the battery. So the voltage in the first resistor is 240, and the voltage in the second resistor is 240 volts. Okay, now the last one, current flowing through each resistor. Here I know that the total current is the sum of the two currents in flowing on in each resistor. So let's see. What I have to do here is to apply, I have the voltage and the resistance. So how can I get the current? With the Ohm's law. The current in the first one is the voltage of the first one divided by the resistance of the first one. In the second one is the voltage of the second one divided by the resistance in the second resistor. Let's see. The voltage is 240 volts divided by R1, but I have to convert into ohms. (2,100 ohms). (300 multiplied by 1,000), 300,000 ohms. Oh, sorry. Divided by 2,100. (0.0012 amps). (0.008 amps). So if I sum these two values, I should get the total resistance. Let's see. is to check if it's right or not. To 0.002 amps. Is the value? Yes. So it's right. Okay. Now you can